So moving on to the main topic today, we're delighted to welcome Johnny Poulsen, CEO of the Lenco Tunnel Systems, as our guest speaker today. With over 25 years of international experience in waterproofing and concrete repair for underground structures, Johnny brings deep expertise and innovative thinking to the complex challenges of managing groundwater and hydraulic pressure. His insights into drainage and mess solutions offer a practical and forward-looking approach to improving tunnel durability and sustainability. So before I hand over to Johnny, if I could just ask that should you have any questions that you would like answered, please pop them into the chat or the Q&A box. We will aim to cover as many as we can at the end of the session. So with that, I'll hand over to Johnny. Thank you again for joining us, and we hope you all enjoy the session. Johnny.
Thank you, Nikki. Thank you for the introduction, and thank you for the invitation, also Mehdi. It's a pleasure to be here today, and I hope you will all join us and ask some questions, and hopefully you will find it useful and insightful what we're going to talk about today. So I'm going to start with sharing my screen, so give me a minute to do that. I will have a slideshow which I will start, and then after this slideshow has finished, there's certain sections there ending up with a number of projects, and after that we'll have a little bit of time for questions as just mentioned before. So just give me a second here. So yes, so welcome to this talk about groundwater, hydrostatic pressure, drainage, how to manage these things when we are talking about underground structures. When we're doing these incredible feats, digging out a tunnel, meaning removing a huge part of a mountain, for example, and just leaving it void, just so we can pass through it. Of course, there's a number of issues with that, because the mountain is many years old and it has its own dynamics. And the first we think about here is the soil dynamics of doing this. It's a tremendous influence on the structure. We have, in that context, we have the dynamics also of the water, which is inside that structure. And of course, when we open up this, we apply a number of lining designs to try to use this excavation safely. And we have put this into 3 times of influence. And the first is the excavation, then when we do the construction, and then after. The excavation, of course, is very critical because we have no safety at all by excavating, so it's a very, very tedious and dangerous work. During construction, we start with typically making a primary liner to make sure we can actually go in and work there. And then over the lifetime of the structure, we also have the dynamics of the surrounding soil and rock, whatever it is made of here. Now, of course, the danger here is that this dynamic changes when you excavate, and it actually also can change over the lifetime of the structure just by setting. The same goes for the water, where we have the as soon as we excavate, the water can pour in because there's water just nearby. We have kind of a period where during excavation and construction, where it kind of takes off the water that's not so much coming in, and then the surrounding water starts accumulating again and try to follow and find a way out during construction. And this is, of course, where we start having problems with our construction of that specific lining that we chose. Working with that design is the critical point, of course. So we have all the aspects covered of what could come and what might be when we are going to do the actual excavation. And then again, after we finalize this lining, we have to also have it functioning over the lifetime of the structure. And the less problems we can have over that time, the more optimal is the rate on return on investment and the LCC, life cycle costs of the structure. Just one close down can be a very expensive feat. So these are the critical parts here, and what we're looking at is, of course, the water and why this is a problem. We all know, you all know about these issues because you are working with them on a daily basis. And of course, it's the nuances it makes when you are making your liner. Water comes in, you maybe have to repair even during construction. You have over the time of the lifetime of the structure, you have the ice, you have the water coming in, you have the spalling, you have the rails, you have the installations, and so on and so on. These are all very costly feats to do. So today we're trying to counter these from 3 different principles. We try to block it, divert it, and we just try to accept it. And of course, these approaches are with different tools. The blocking, you can grout it, you can waterproof it, you can divert by line drains and other remedies. You can just accept that it actually seeping, put panels up in front of the seeping, and then you have all the long-term repair issues like the injection, the concrete repairs, replacing installations, refurbishment, and so on. Also, we have the design components, the concrete. We can also play a little bit around with these parts. Where we can have the concrete fast setting. You can use it, design the concrete with different additives for the cracking. You can also choose to use more concrete. You can use stabilizers like steel girders, anchors, wire meshes. And for the drainage, you also have different options. The dimple sheets, you have geotextiles, and you can use hoses and so on. So there's a number of parts there as well. Then finally, we have the waterproofing part, which starts with the grouting, and then we have the different membranes, the spray membranes, sheet membranes. You can add fibers to your concrete. You can also use crystalline waterproofing, and you can do the injection, post-injection for the waterproofing. All these solutions, they have one problem in common, really, and that is that you really never get rid of the hydrostatic pressure on which is the main problem. And that's what we have been looking at with our more than 25 years of experience with waterproofing. We basically looked into and said, okay, if we can manage that hydrostatic pressure, then we can solve a lot of issues in the structure, and maybe even give a longer lifetime, or lower life cycle costs. And this is how we actually, from this point of view, developed the Dolenko drain for tunnels and other underground structures. What is specific about it is that it will permanently prevent water pressure. And this is, if you take anything with you from here now today, it is that is the main feature of doing this solution as part of the lining, permanently preventing water pressure. As you can see here to the right, this is some of the conditions that we are working with and which we also have solved with very little remedies, and if this is possible. Before talking more about the specifics, I'd like to give you an illustration with a small video here about the principle of the Dolenko drain. And before I start the video, it's like what you see here. You have the bedrock, you have an initial shotcrete layer, which is typically 30 millimeters thick, so that you can nail Dolenko drain modules onto that surface with 30 millimeter nails. No anchors needed. And then after that, you finalize with some kind of design of inner lining. Let's start the video. You will see these half pipe receiving the water and lead it to the base on the side. So we avoid the pressure on the inner lining. as you see here, it's fully embedded into the concrete. You start mounting the modules from the top, and you can see it's a standard module size, overlapping horizontally and vertically. So water can actually disperse sideways and vertically. And at the bottom, some kind of detail for alleviating the water. Okay. So as you saw in the video, it's a module-based system, and these half pipes, you can see them very well embedded in the picture there, down to the left. So it's a very slim structure that you can do, and this of course has some advantages. The module itself is about 1 square meter, and that is 80 by 120 centimeters, and only 14 millimeters thick. And this, of course, is the advantage of being able to make such a slim structure with a complete drainage inside. More schematically, you can see here the mounting together, and this is also something we can send to you after. To the top left, you see the vertical connection, and you basically just overlap the strings, so the water can go from one module to the next. And below that, you see the horizontal connection, which makes sure that the water not only goes from one string to another, but also from one module to another. And there's in those two joints, there's a lot of flexibility built into them because of the unevenness of the surface. It's very common that there's an unevenness of the surface. They have been designed for this purpose. And then there's a designated number of nailing points shown to the right. So what do you get when you have put the Dolenka drain into the structure? As you can see on the picture here, it's covered with a shotcrete layer of about 50 to 100 millimeter and fully embedded. So the primary and secondary concrete now is permanent lining. And this gives you a very, very strong drainage concept inside. And it can take up to 8 cubic meter of water per linear meter wall per hour. So this is a very, very high volume of water. If you have this type of water ingress, you'd have to do something before putting on the second shotcrete layer, because it will simply not be able to adhere to the concrete. And since it's embedded inside the concrete, it doesn't go away. It's a permanent solution. And the material is also made of a material that can be 100% recycled. After breaking down the structure again, it doesn't go bad, so it will just remain permanent in there. Besides the tunneling projects, you can also use Dolenka drain on other types like second pile walls, slopes, and other underground structures. And of course, it can be used by both the existing and new tunnels. There'll be some examples of this later as well. So, as I mentioned before, the main focus is to permanently prevent water pressure. This also gives you some advantages during construction. For example, if you're using a spray membrane, often we have the water accumulating behind the spray membrane before it hardens. So when you have installed the Dolenka drain behind that, it will receive the water before the water goes to the place where the spray membrane is. So the spray membrane will have the opportunity to harden properly and be fully functional. And at the same time, you also eliminate or minimize the need for injection during construction. So let me show you a small video of how it is actually being mounted. Here you see the mounting from a scaffold. It can also be from a scissor lift. And this is from a road tunnel in Colombia. Okay, so now I mentioned this, that it's a very slim structure. And of course, since you have the, as you can see on the picture here, you have when you mounted the linker drain onto the wall surface, when you add the next layer, you have adhesion between the strings. And this area is 70% of the surface where you have full adhesion between the two concretes. And this is how you make it into a monolithic structure. So in this case, you will probably be able to calculate less concrete on the secondary lining, because both primary and secondary lining are permanent linings now. We tried to compare to different other situations in hard rock and soft rock tunnels. And we looked at three factors. We looked at the direct cost, then we looked at the time, and then, of course, because of that, we also looked at the derived carbon footprint. And in all three of these factors, we saw a significant reduction of the cost and time and the CO2. And this is partly because of the less concrete. It's also because of the fast way of working with Dolenko drain. It's a very lightweight solution. So as you can see here on the right, this is a picture from a tunnel in Spain where where I don't know if you can see that, but this is a scaffold built over the rail, and it's actually built so the train can still run during construction. So it also illustrates how little space we actually need to mount the linker drain, and this is of course the reason it's possible to save on time. So where to use? Now there's a number of different situations I'll go through now, which you see written here. On rock surfaces, we talked about that. On second piles, and then on horizontal surfaces, it could be on an invert. Then you have on slopes, or you can mount directly onto rock in certain conditions. You can use the linker drain on brick surfaces, which is very relevant in London, for example. And then you can also use the linker drain on uneven surfaces. And let me show you an example now of a second pile application. Oh. Wait, just a minute. What you see here is leveling between the second piles first. Mounting the linker drain. And in this case, it's a combination of wall and floor, where the water just simply flows into the wall version and into a pump pump. It's covered with 50 to 80 millimeter shotcrete. The floor version is a little bit different because it has to take load, and so it's a more stiff version. Okay. So as we saw in the video, you just, after having the second piles, you just fill out between the second piles and not cover the second pile with a lot of concrete, just to level it out. It has to be wavy so that the modules can be mounted onto that surface. It doesn't have to be absolutely smooth, flat. So you just mount the drain onto that, and then you cover with shotcrete over that. Then you can combine with different types of gutter solutions at the base. Here we see the Dolenko gutter drain, our own gutter, which is mounted in. This is specifically for very slim structures. This is a 65 millimeter wide gutter, which can be used specifically also for repair projects where you don't have too much space to do with. On the rock wall, we have the primary shotcrete, the Dolenko drain, and here we'll see it also combined with the vertical line drain. And the line drain is for points. If there's a lot of water coming out at a point, it will encapsulate this so we can get the shotcrete to stick to the surface. And then you use the Dolenko drain mounted around that after. And here it's shown with the 2 layers of shotcrete over Dolenko drain. And this is typical that we do this because if the first layer has some defects, using it in 2 layers will make sure that you have a solid barrier for the water in the secondary layer there. Here we have with slopes, where you start with an initial shotcrete layer, then you cast a concrete with wire mesh and anchors, and put the Dolenko drain in there. And after that, you cast concrete with wire mesh again. And of course, this is instead of using the system where you have a lot of pipes coming through the surface, which has a number of problems for durability over the lifetime of the structure. So you can also, in certain conditions, you can use the Dolenko drain straight onto the rock. The issue is, of course, that if the surface is not very smooth, there will be when you shotcrete it, there will be some of the strings will be blocked because of the shotcrete, but the water will still find the way. And the way it's done is just mount it with a wire mesh to hold it onto the surface. So you basically anchor the wire mesh over Dolenko drain, shotcrete it, and then the picture you see here to the right is from a project where that made it possible to get the shotcrete to stick to the rock, and it stopped also 80% of the water flow. And the remaining water flow was stopped simply by casting concrete onto this. And it makes sense because when you have cast the shotcrete first, or shotcreted the shotcrete first, and then when you cast concrete onto that, the water is not trying to get through all that concrete. It will just find a way back into the mesh and alleviate the water pressure that way. Water will always find the easiest way out. So this is a very pragmatic way of working with this situation where you can't get the shotcrete to stick to the rock surface. On the brick surfaces, you will of course before you start with the Dolenko drain, you would go and check all the joints and make sure they are repaired and they are updated. Then after that, you can either mount the Dolenko drain directly onto that, or if it's hard stone, you would put a thin layer of shotcrete or mortar onto the surface, and then mount the Dolenko drain. Plus, it could be like here with a mesh, fine mesh. This is a fiberglass mesh, and then either a render or a shotcrete over this, depending on the preference of this is typically the contractor who decides which method he uses for that. And then I mentioned how the uneven surfaces can be done as well. And as you can see here, it's a very, very flexible application. As long as there's no sharp edges, just wavy surface, then it's possible to put the Dolenko drain on that surface. And I'll show you a little bit of video again. A little bit more show here. And this is to illustrate the unevenness of the surface, of course. Here you also see the nail gun with the battery. So you can have two people on a scissor lift like here, and they can mount between 12 and 20 modules or square meters per hour. Okay. So when we put the Dolenko drain onto these surfaces, I mentioned the line drain, which is number 3 here on the illustration. We also have a very good success with combining with 10 millimeter rubber hoses. And what is illustrated here is point number 1 is cracks, where we normally don't do anything to the crack. We just let them leak and leak into the strings when you shotcrete over them. But if you have more water and it damages the concrete during application, then you can also use this 10 millimeter rubber hose, as you can see here, point 2. And what you basically do is you just drill a hole where the water is, and you have a hose that you just lead into the nearest string of Dolenko drain, and then shotcrete over that. That basically takes most of any of the issues with water coming in, unless they're very severe, which in that case you'll go to point number 3 here. The video from the very beginning, where you saw the water running in the tunnel, that was actually managed only by shotcreting over it in 3 layers consecutively, and then in between that using the rubber hose method here. So that basically solved all the issues there. Now at the base, in the video, there was a perforated pipe shown, and you've seen our gutter detail as well. There are a number of different possibilities there that we normally see being done, and one is a perforated pipe at the base, and then cover the end of the modules. You can see here. Let me just expand this a little bit so you can see better. So you have Dolenko drain modules, water coming down here. You install the perforated pipe, and then you put a strip of geotextile over the end of the module and around the pipe. Just the end of the module, not the whole module, the whole wall, just so that there's no possibility for shotcrete to block the end down here. This is a very common method of doing this. Here we have basically the same situation, but this is with a membrane included. So this can be a spray membrane, or it can be a sheet membrane included here. Here we have another situation. If you, for example, have a shaft, you could also just let the water run out on top of the slab. So what you do, you basically put, again, the geotextile strip over the end of the module and shotcrete, so you have leaving an opening at the base so water can come out. Very simple. And here's a detail from, this is from more detailed shaft, but I only want to show you the detail E here. We do like this. And this one illustrates how you can also simply let the Dolenko drain modules pass the slab and lead the water into a stone drain layer beneath the slab. In this case, what you do is you mount a strip of geotextile over the area when you're casting the concrete. Otherwise, the cement paste will penetrate into the strings and block them. Yeah. And here the last one is the Dolenko gutter drain, which is, as I mentioned, the advantage there for this is that it's only 65 millimeters. So that in that case, it's a good for when it's repair and other those type of situations where there's a little space. And what you basically do is you place the gutter over the end of the modules and nail it to the surface. And then at certain intervals, you mount horizontal pipe to lead the water out to whatever detail is specified in the project. This is also something that we spend quite a lot of time doing, is discussing these details with when there is an individual project. So we have teams meetings about this to discuss how to optimize the use of Dolingo drain in these situations. So how has it been used? I've included a number of different types of applications here to give an illustration of this. And the first one here is from a road tunnel in Switzerland. And the road tunnel actually collapsed. And there was a problem with of course, first to rebuild the structure. And then there was very little space to do any work inside the tunnel after that. And for that reason, they chose simply to mount the Dolingo drain on the surfaces and just cover with a shotcrete layer, a very slim layer of shotcrete. So that I think it was 50 millimeters, and that worked perfectly. Here we see the first project on top is from an existing tunnel that was more or less made into a new tunnel, because it was two tunnels with a wall in between, two single tunnels with a wall in between, and they removed the middle wall, expanded the tunnel, and put in steel girders to reinforce the arch. And then the principle was to put shotcrete, smoothing layer, spray membrane, and shotcrete. And during this construction, the spray membrane, the surface was dry for 24 hours like it should be before applying the spray membrane. But the problem was that after the spray membrane was applied, the water accumulated still behind and made damages to it. So there was a lot of problems with that. And for that reason, during construction, the designer changed the design and included Dolingo drain behind the spray membrane, so it could take the water and prevent it from going to where the spray membrane was applied, and let the spray membrane be fully installed. And that was successfully done. Yes, it was also with the umbrella. There was also an umbrella system, so there was kind of a section-wise jump, which also Dolingo drain could accommodate to being very, very flexible there around that. Below that, there's a shaft, and this shaft was the special about this shaft is that the lower part is hard rock and the upper part is soft rock. So it's an interesting, where you at the base of the lower part had a rock surface with shotcrete and anchors, and the upper part is second piles with the shotcrete to level out, and then the whole surface used with the Dolingo drain on that surface, and then after that it's covered with 50 millimeters shotcrete, a spray membrane, and then another 50 millimeters of shotcrete. So that was a very, very easy way of saving a lot on concrete and formwork. And of course, the inner lining, the difference is also that the inner lining does not have any pressure on it. And this is a ventilation shaft, yeah. Here we have a couple of basements. I'm not going to say much about that. Examples of second piles. Here we have a road tunnel, which was a very, very old road tunnel from 37. And it was actually closed because there's too much water running through it, through the ceiling. And the reason is that there's a river. So there's a lot of water coming through. And you can see on the picture here that it's a very bad concrete. And for that reason, they had to remove the bad concrete, clean the reinforcement, put on corrosion inhibitor, rebuild the layers with shotcrete, Dolingo drain, spray membrane, and this actually made it absolutely dry after that. So that was a good success. Below that, an example of a retaining wall where there was no other option than just remove the outer layer of concrete, put the Lenco drain in, and then apply a layer of concrete over that again. And this is in Philadelphia, we say the other one in Moscow. And here we have a project from Mumbai where they changed the design from a sheet membrane, double lining with sheet membrane, to a shotcrete lining. And in parts of it, they used Dolenko drain and also other types of water drainage system. What you see there on the picture to the right next to Dolenko drain is not our product, it's a line drain. So use different types of products there because the shotcrete and the spray membrane doesn't have a drain behind it. So when they changed from the sheet with a drain behind it, they also included this in the new design. And here we see an underground railway station, plus the ramps with second piles. And you can kind of see on the picture there, you can see the second pile the contours. It was leveled out between them as specified, and then put on the Lenco drain. And here it's with shotcrete, spray membrane, and shotcrete again.
Okay, excellent, Johnny. I would say that was an excellent presentation. Thank you very much. It was really good. It was interesting to find out how your system works. So we have several questions in the chat, some very good questions. So yeah, well, to me, the best part is just when you explained about the benefit of this method is just to reduce the hydrostatic pressure. So this is something that when we use other techniques, a lot of techniques, we may stop the water or control it, but actually the water is there, and that additional force on the lining or the shotcrete requires some work to ensure we have enough concrete or shotcrete to resist that hydrostatic pressure. So that's a great benefit I can see in this method, but just instead of keeping the water there, to try to divert it and reduce that hydrostatic pressure, that can result in reducing the concrete. Because I was looking at the chat, there were some very good questions. How can we reduce the concrete? I leave it to you to answer. But to me, if you can divert the water, potentially, if you go back to the designer and can exclude the water from behind the concrete, you might be able to optimize your design and reduce the concrete. So, yeah, I don't want to answer the questions in the chat. Well, I leave it to you.
Well, I can comment on that because we have we actually have a specific situation where we were told by the designers that they save tens of millions of dollars in because of this and reducing the concrete and not having to put up the formwork and the time they save was tremendous. So this is of course it depends on the project what it is you're saving on. But there's definitely a huge potential there. And there's another point which is important here is also that when you talk about this hydrostatic pressure, that when you avoid that during the lifetime of the structure, then if you can just avoid one shutdown of the tunnel in that lifetime, then you have huge savings, right?
Absolutely, absolutely. To me, if you can divert the water, and if the designers can exclude the water pressure behind the lining, that can reduce the thickness of lining, and that can result in a saving. Let's assume you have a 2 kilometers tunnel, and if you can just save a little bit which will be more than that. From the thickness of lining, it can be a huge saving for the project. Yeah, excellent.
Well, when you do that calculation, I mentioned that in the presentation also. But the important thing is that as designer, that you think about this as you have 70% of the area free for adhesion between the primary and secondary lining.
Yeah, excellent. So I'm conscious of the time, and I know that there are several great questions in the chat. If anyone has any question, you can ask your questions in the chat. I'm just going through that quickly, asking some of these. So I think there was a question that how come it is useful in the reduction of concrete consumption? Can you explain that? Which I think we touched, but do you want to add anything?
Yes. Well, now the point is that when you have the primary and the secondary lining, typically the primary lining is a temporary lining, right? And the secondary lining is considered permanent lining. And when you have a monolithic structure where you have adhesion between the primary and secondary lining, you can actually calculate the primary lining also as permanent lining.
Okay, so I get your point. Yes, so there are two benefits. So I was thinking from the other side, but actually, yes, you are right. Excellent.
Well, if you compare to there's two specific cases where you compare that to that. That's when you have a sheet membrane, or if you use sometimes what we call dimple sheets. I'm not sure what the right term is in any country, but I don't know if you know what these dimple sheets are, but those when you have a layer that separates, when you have a sheet membrane, you have two concretes, right? One on each side.
Exactly. Yeah, that is the problem.
No adhesion.
Yeah, that is the problem. So yes, you are right. So, well, personally, I've been involved in it. That's one of the items that we always consider. I don't want to go against the sheet membrane because it has some benefit in some conditions.
Of course.
But yes, when you are using a sheet membrane, the problem is you are actually separating the primary lining from the secondary lining. Therefore, designers in their calculation usually should exclude the impact of primary lining, and they assume that there is no primary lining. Therefore, in their calculation, considering all the pressure from the ground and groundwater, they need to increase the thickness of secondary lining to be able to design as per design. So that was a great one.
And for that reason, also, you can actually combine the Dolenko drain with the sheet membrane as well. So you mount the Dolenko drain behind the sheet membrane.
Therefore, there is no the water is diverted behind the sheet membrane. Yes, absolutely. Yes. Okay, excellent. Yeah, that was great. So there is a question here. It says in two shell lining, where the second when we have two layer of linings, this primary and secondary, where the second layer of concrete, how this will be effective, how collected the water. I think you have mentioned, but do you want to add about the installation between two layers? Is there any explanation you want to add here? I'm not sure if I've understood the question completely.
No, I think the question is about this, how, well, if it's double shell lining, I mean, no, I think we touched about this on this about the adhesion between the two layers on both sides of the Dolenko drain, but there is I'm not sure if this is part of the question, but you can say that if you want to cast concrete onto the Dolenko drain, normally we shotcrete, but because you can't cast concrete onto the Dolenko drain because the cement paste will fill up the strings, right?
Yeah.
So what you do is we recommend that you just cover the Dolenko drain with 2 centimeters of shotcrete and then cast onto that.
Okay. So we have another question exactly about that. Can the Dolenko module be installed over a fresh shotcrete? If so, is the channel not blocked when installed on fresh concrete or shotcrete? So.
Well, it would not be, well, in real life, you'd never do it on fresh concrete. It's always setting fast, right? The shotcrete that you're using is fast setting. So you never have a situation where it's soft, like where wet in wet, like we call wet in wet. That doesn't happen because you shotcrete, and then it sets in within hours, right? Enough to you can nail it, but you typically nail the day after or later. So it's a firm surface that you're actually applying Galenko to.
Exactly, especially if you are using shotcrete. If the shotcrete is wet, it's not safe enough to go into that area. I would say if the shotcrete is wet, you shouldn't go to that area to install anything. You should. Well, in the UK, there is very strict regulations around entering the area when there are wet shotcrete. So, and we do a lot of testing before entering. I would say if the shotcrete is not strong enough, you shouldn't go into that area to install anything.
Of course.
Okay,
yeah, of
great.
Course.
So, and there is another great question. How can Galenko be installed when the excavation support has a steel rib element that needs to be installed immediately after excavation? The combination of a steel rib and this material.
Yes, that's a very good question. I only touched it very lightly in one of these projects that we did, but they actually did put in the steel ribs and in sections. And what they did in that case, you could do two things. You can either mount the Galenko drain between these two. This will depend on the expected buildup of the entire lining. What I would recommend, but you have two options. Either you do it between the two in sections, or you wait till you have the concrete covered up to the level of the ribs, and then you put the Galenko drain on the entire surface. I like the last one best, but again, it depends on how much concrete you have to work with there.
Okay, yeah, excellent. Thank you. Let me just read as much as question as I can. Are there any study results available on the composite section of the concrete with the Galenko drain to evaluate its impact on the shotcrete section? So the question is, when we have this, your product, and we have the shotcrete, what's the impact of this on the concrete and the quality? Would it be any void behind that kind of things?
Yeah, no, there's no void. So the only thing we have, which we know in general, is that you have the adhesion. The most important factor is the adhesion between the two concretes. So basically, it doesn't have anything to do with the Galenko drain. So it's important that you have good adhesion between the two concretes, and sometimes a primer is used there for that.
Okay, excellent. There is another question asked, could this work be on basement, floor and walls?
Yes.
I think you explained, yeah.
Absolutely, absolutely, yes. This is one of the big areas of application. Typically, it's second pile basements. That's a huge area, yes. And the floors.
Also,
and if you have any specifics on that you want to talk about this, I'll be happy to take an individual session following our meeting here and arrange for that. That can be done. If there's also any other project related, whatever.
Okay, excellent. That could be a suggestion. Yes.
Sounds specific, yeah.
Yeah, and another one, could this replace a cavity drain membrane system?
Yes.
Yeah, the simple answer, yes. Great, we like it. It's short and simple. How come it would be helpful or considered for the seepage that passes or coming through the floors? From the water that's coming from the...
Yeah, how is that being used? That's a good question, because for the floor, it depends on which country you're from, because there's different types of building methods. We see this when you have a double structure floor and you have pressure from water underneath coming up around pipes, through cracks, or through the joints from the sides. We know that it's very difficult. For example, if you have a sheet pile wall and you have just cast concrete to it, it's very difficult to get a membrane under that to actually become waterproof, just because of the environment you're working in, right? And so you put a water stop on the side, but water has a way of getting in, and also between the wall, the floor and the wall, the joint there, water coming in, all that water coming in on top of the slab. So we built a double structure with sometimes we use 25 centimeters of a stone drain layer, and then maybe even an insulation plate, and then the final floor. So this is how you do it. So it's because of the water pressuring in from sides and from underneath. And then you
Okay,
capture the
excellent.
water in the net, and then you typically lead it to a pump sump. Or one or more pump sumps are made on the floor, depending on the size, of course. And the question can also sometimes come that, do you need slope for that on the floor? And the question is, no, you don't need slopes. You just have a number of some pump sumps, and that's it.
Okay, excellent. So I'm just conscious of time, and I would like to finish before 1 hour because everyone's time is valuable. But I would like to read all the questions. So let me just read a couple of more. What is the lifespan of Dolenko drain?
Well, it doesn't really go bad. It's the material is LDPE, and you can basically in 120 years you can take down the wall, you can separate the material, you can take the Lenko drain, and you can granulate it, and you can make new products from it. It's chemical resistant, so it does deteriorate over time.
Okay,
And this is one of the reasons. This is one of the reasons that we chose this particular material. It's very recyclable, and it's also very flexible and lightweight. And so there's a number of yeah. What do you call that?
So yeah, okay.
Reasons for
So
using it.
yeah, well, I'm sure it will work for the design life of the project. It should be the design life of that should be more than concrete. I think, I believe so. Can it incorporate some help to load bearing? I'm not sure what it means, but
about load bearing, of course, it's not about walls we're talking, I'm sure. It's about the floor, and the version for the floor is a different material. It's more HDPE, LDPE. It's load bearing, designed for load bearing. If that's the question, that's normally what we're talking about.
Okay, so there is another question. How would you, if this is the case, how would you calculate the face pressure stability? Again, I'm not quite sure. Are we talking about TBM tunnels here, or I don't know? If I leave it to you. I just read the question.
I'm not sure. I'm not sure about that.
Yeah. Well, some of these questions, if there is any question, they can ask again, and then we provide the question. Well, working as a consultant, I like to answer the questions myself, but I leave it to you. So there is another question about the lifespan, which you answered. Also, it asks about what is the minimum concrete or secondary lining thickness that requires for installation of this? Is there any minimum requirement for concrete?
That's a very good question, and we've been using the Lenko drain with very slim structures. Really, of course, primarily it depends on the water volume and the water pressure coming in. But we are at I would say minimum, if I pressure myself, 40-50 millimeters. 50 millimeters. That's typically what we are down to. But that again is dependent completely on the project, and we would have to talk about that in detail. But we have seen just a cover of 2-3 centimeters actually being able to stop water that is dripping in. So it's very robust.
Okay, perfect. We have a couple of more questions. Is there any application in segmental lining tunnels such as TBM tunneling? I think that was my question initially when I met you couple of years ago. So is there any application in TBM tunneling or not?
Well, the only place we see in TBM tunneling is if you have an open TBM where you want to just keep the machine going, where you can put the Lenko drain on the ceiling to just temporarily divert the water to the side. You just mount it directly onto the rock, shotcrete it, imperfect, but it works, and then you can just keep going. So that's the only application I see there for temporary purpose.
Excellent. Thank you very much indeed. That was a great presentation. Great questions from some people. And there are some other comments in the chat as well. So I would say if anyone has any question, you can ask or you can communicate, and then we can send you the questions. Also, in the chat, there were some comments about some people were not able to hear. Maybe they had a problem with their system, because we could hear it. That's why probably we have saved we have recorded the whole presentation, and we decide how we want to distribute that to people, to ensure if you had problem or if you want to go back to that, you should be able to go to the presentation and watch the video again if you require. So I would like you to thank everyone. Nikki, are you here?
Yes, I'm still here.
Yeah, okay. So yeah, you can close it. I hand over to you. Thank you very much, Johnny. That was a great presentation.
Thank you, too.
Okay.
Thank you, everybody.
Perfect. Thank you, Johnny. Thank you, everyone, for attending. We're now going to end the session. Thank you.